Dear students, I am Santan, working as a physics faculty in Target English Medium School. Today, in this part video, I would like to teach how does sound travel through the air, and after that we discuss that is really sound has energy or does sound has energy. These two topics mostly we discussed in this part video from the chapter of sound. And already in our previous video in this chapter we clearly discussing about what is the sound, how the sound is produced from the vibrating bodies. These topics we discussed in our in our previous video. Now our concept is how does sound travels in air. So before going to discuss this topic, first once again we remember sound is which type of wave. I says that it is a mechanical wave, in the mechanical wave it is which type of one? It is a longitudinal wave. So sound is a mechanical wave. Mechanical wave is nothing but a wave which requires a medium for their propagation. That's why sound is also needs a medium to propagate, is nothing but to move from one place to another place. But the sound is travel through the air in which form of the wave? Longitudinal wave. Because mechanical wave further classified into the two types, I said clearly, progressive wave and stationary wave. Progressive wave further classified into the two types, longitudinal and transverse wave. So our sound is a mechanical wave. In the mechanical wave, how it is travel through the air from one place to another place means in the form of longitudinal wave. Which type of wave we are called longitudinal wave? I says that the position of the vibrating particles in a medium. So the position of the vibrating particles in a medium parallel to the direction of propagation of the wave is nothing but, so if the sound energy is traveled through the air, in the air the vibrating particles, why vibrating particles? When the particles are vibrated, at that time only energy will be transferred, which one? Sound energy. That's why by the vibrating of the particles or by vibrating of the objects only sound is produced. That's why in the air particles are there. These air particles are during the carrying the sound energy from one place to another place, they vibrated. I will explain later. They vibrated and transferred the energy from one particle to another particle till end of that energy will be vanished. So that's why in that way the vibrating particles in the air are the air particles during the transfer of energy. Air particles are vibrated parallel to the direction of the propagation of the sound. So that's why, listen very carefully once again, sound is a mechanical wave. But the sound is travel through the air in the form of longitudinal wave. The longitudinal wave must be contained compressions and rarefactions. So means a wave is belonging to a longitudinal wave. It must be travel in any medium when the wave must be a longitudinal wave. If a wave is a longitudinal wave, that longitudinal wave during the transfer of energy, it must be travel in the form of compressions and rarefactions. Which is what is compression, what is rarefaction? I will explain with the help of the diagram neatly in this slide. So, let me come to that one. How does sound travels in the air means? Sound travels in the form of compressions and rarefaction through the air, because the sound travels in the air is a longitudinal wave. Listen very carefully. Sound travels in the form of compressions and rarefaction through the air because it is a longitudinal wave. So, means first of all we can take a tuning fork and a rubber hammer. The prongs of the tuning fork is strike with the rubber hammer. Then what will be happen? The tuning fork will be start the vibration. It's nothing but the prongs of the tuning forks are start the vibration. They produce the sound. Okay, thus air particles which are near to this one, they during the vibration, the air this vibrating tuning fork is touches to the air particles in its surrounding area. That's why the air particles will be absorb the energy by contact with the which one tuning fork. Then the air particles will be start the vibrating. Then these vibrating particles will be transfer the energy to the neighboring air particles. Then again the neighboring air particles will be absorbed and transferred to the next one. Like the same way, sound energy will be transferred from one place to another place. Is nothing but here what your understanding means in this way. So during the transfer of energy, which one sound energy, from one place to another place, the particles in a medium cannot be transferred from one place to another place. Only they transfer the energy. Listen very carefully. So if the energy will be transferred from one place to another place, during such a condition, particles in the medium is not transferred. Is nothing but particles in the medium is not moved from one place to another place during the carrying the energy. Just they transfer the energy to the neighboring particles. How means? So first, before going to the example, I put it normally. So in a classroom, so teacher is the source of the sound and the students are the listeners or observers. The teacher will be produce the sound through his mouth. So by telling any words regarding the subject. At that time, just you can say that when during the speaking, when you can keep our palm very near to your mouth, you feel some air force will be touches to your palm according to the releasing of voice or coming of voice from our mouth. So that's why what is nothing but here. So like the same way, the air particles which are present near in front of our mouth because of air is present everywhere. So when the sound will be coming from our mouth, at that time the air particles near our mouth will be start the vibration, because of it will be forcefully come and touch. When the forcefully will be come and touch, the particles will be start the vibration. So that's why here just we observing that this is the a portion of the air particles, this is another portion of the air particle. This portion of the air particles near to our mouth. That's why so forcefully the sound energy will become and touch this one, then it will be start the vibration. During start the vibration, these particles are comes closest to the second portion and comes close to the second portion and touches to the second portion of the air particle. By contacting, what will happen? Energy is transferred. Which energy? Sound energy. Then again comes to like this one. That's why initially listen very carefully. The first portion of the sound particles comes close to the second portion of the air particles during the contact. This is called compression. These particles are comes close together. After that, again the first portion of the air particles are comes to back, because of this is called vibratory motion. So the particles will be moved from to and fro motion. From its the mean position is called vibratory or oscillatory. That's why first close to come, that is the compression. Again moves away from that one, that is called rarefaction. Next, the second one. After observing, it is also start the energy. Then this goes to second one. Means next second, third portion of the vibrating particles goes towards this one. Compression, rarefaction. Next this one. Compression, rarefaction. Is nothing but here. What will happen? The portion of the air particles will be during the contact with the neighboring portion of the air particle. They transfer the energy. That's why energy is only transferred from one place to another place, but the particles are not transfer energy along with it. That is the way of that one. So listen, sound is a mechanical wave. It needs a medium for its propagation. Sound travels in the form of compressions and rarefaction through the air because it is a longitudinal wave. Next, in this one, the energy only transferred from one place to another place, but not the particles. Is nothing but energy is only transferred from one place to another place in a medium, but the particles are not transferred from one place to another place. And next one, the density of the particles the pressure and density of the particles is more at the compressions, and density and pressure of the particles are less at the rarefaction. We know that pressure is equals to, what is that one? Force upon area. Density is equals to rho or d. Density is equals to mass upon volume. So here the force is acting from our mouth is constant. Pressure is constant. In this one you are observing that area. Here what is that one? Volume. Mass is constant. So density is depend upon the volume, pressure is depend upon the area here according to this. So area, volume is nothing but area into height. That's why indirectly volume means area is also included. So in this one, when the particles are close together, means particles are near to each other, then what will be happen? Area or volume is less. If area is less, pressure is more, because of these two are inversely proportional. Like the same way, density is inversely proportional to the volume. If volume is less, density is also more. That's why at the compressions, all the particles are comes close together is nothing but they occupies the lesser area or volume. Due to that reason, pressure and density is more at the compression. But at the rarefaction, the particles are move apart with each other. Is nothing but they occupies the more area when compared to this one. Area is nothing but volume. So they occupies the more area. Area is more, pressure is less. Volume is more, density is less. That's why at the rarefaction, pressure and density is less. When sound is travel in the form of through the air in the form of compressions and rarefaction. So how does sound travels in the air means? So what we can write means, first we can draw this diagram. After that, sound is a mechanical wave. It needs a medium for their propagation. This is the second one. Sound travels in the form of compressions and rarefaction through the air because it is a longitudinal wave. Next one. The particles in the medium is only transfer the energy from one place to another place, but the particles are not moved from one place to another place. Next point. Pressure and density is more at the compressions and pressure and density is less at the rarefaction during the transfer of sound energy from one place to another place. Like this mode, sound energy is transferred or travel from one place to another place through the air. Next one is sound has energy. Is really sound has energy or not? We are discussing in this topic. So in our previous video we discussed that sound is one of the form of energy. It causes the sensation of vision. With help of this concept we can prove two ways. One is, so we discussed that sound is produced from the vibrating bodies, and also okay means when a body is vibrated it produces the sound. That is the one. Next thing is okay, sound is produce the vibrations also. That's why one question they are asking regularly to confusing about you. Okay, in a statement they are given that vibration of a body produce the sound and sound produces the vibration. Among the two, which is the correct? You can explain. Both are correct. So in previous video we discussed that vibrating bodies are produce the sound. But with help of this experiment we are easily understand sound is also produce which one? Vibrations. That's why both statements are correct. Anyway, with help of this concept, we can prove the two. One is sound, really sound has energy. That is first one. And the second one is sound is also produce the vibrations. That is one. So in this one, we discussed one small experiment. That is mobile phone experiment. Mobile phone or cell phone experiment. Mobile phone or cell phone experiment. So here, when you are conducting any experiments, what are the materials are required to proving really sound has energy or not? Means we want plastic container, mobile phone, rubber stamp, thermocol balls. So first of all, we can take an empty plastic container and a mobile phone. Mobile phone keep inside the container without on the music player. After that, the open end of the mouth of the plastic container is closed with the rubber stack and tied with the rubber band. Rubber stack is nothing but some part in the rubber balloon, that is one. So after the open end of the plastic container is closed with the rubber stack and tied with the rubber band. After that, now we can keep some thermocol balls. We know the thermocol sheet is the thermocol sheet. Small spherical balls are there or not? That's why the balls are light in weight. That's why we are using this one for observing this phenomena clearly. These are that one. Initially, so you start the time, or you are observing that here after 2 minutes, 5 minutes, 10 minutes, 15 minutes, 30. After 1 hour also, there is no movement in the thermocol balls. They are still in the rest position. Still in the rest position means what you are understanding here. No force is acting on the balls. That is the meaning of that. In the next condition, now we on the music player in the mobile phone or cell phone and keep the volume is a maximum, and again repeat the same experiment. When you can repeat the same experiment in the second time, you are observing that the thermocol balls are move up and down. Is nothing but you see the dancing of thermocol balls. So the dancing of the thermocol balls are represented. What is the meaning of that one here? How the thermocol balls are dancing in this one? When the music will come from this one, means music is nothing but it is a sound or not. That's why the sound energy will be come and touch to the sound is come and touch to the rubber stack. When it is touched to the rubber stack is acts as a diaphragm here. Then the rubber stack will move up and down. Is nothing but it start the vibration because of diaphragm is nothing but it is a light in weight. The diaphragm we can able to see in the microphones and the speakers also. A black portion is there, that is the diaphragm. So some uses are there about that one. Anyway, leave it. Here the rubber stack is acts as a diaphragm. That's why the sound is coming from the mobile phone. When you are playing the music, any music, it will be touched to the rubber stack. The rubber stack is light in weight. That's why it start the vibration. When it start the vibration, the thermocol balls also move to start up and down. That's why you are clearly observing. But actually, you are directly not observing the motion of the which one rubber stack, vibration of the rubber stack. But you can able to see clearly the motion. Dancing of the thermocol balls. That's why it is represented that sound has energy. Is it correct or not? Because of energy is nothing but the capacity to do work is called energy. That's why here work is done or not. How the work is done? Initially the thermocol balls are in the rest. But when you can play the music, at that time the thermocol balls are moved from their position to another position. Is nothing but by acting some force it will be displaced. Is nothing but work is done. So that's why we can say that sound has energy. That's once again listen very carefully. First of all, we can take an empty plastic container and a mobile phone. Initially, mobile phone will be kept inside the container and the open end of the container is closed with a rubber stack and tied with a rubber band. After that, now we can keep some thermocol balls on it and observe the position of the thermocol balls up to 1 hour. So there is no change in their momentum. Next, in the second case, you on the music player in a mobile phone and keep the volume maximum, and again we repeat the same experiment. In the second time, you are observing that the thermocol bars on the rubber stack will be start the dancing. Is nothing but move up and down. That's why here, so how they start the dancing is nothing but, so in this one you are not apply any external force on the rubber stack or on the thermocol balls. But how thermocol balls are moved up and down means, so the sound is coming from the mobile phone during the playing of the music. Okay, at that time it will be touched to the rubber stack. The rubber stack will be start the vibration, because of here rubber stack is acts as a diaphragm. That's why if rubber stack will be move up and down, then the thermocol balls are clearly showing the rubber stack is moving or not. In this one, what you are observing that first thing, sound has energy. That's why only the thermocol balls are displaced. Next one, what is the second one? I says that the sound is produced the vibrations also. Is it correct or not? When initially there is no sound produced from the mobile phone, is nothing but when the mobile phone, when no music player is not on, at that time the thermocol balls are not changes from their position. But when the music player will be on, is nothing but sound will become. That's why at that time only they start the dancing. Is nothing but sound is produce the vibrations also. Once again, is a it is very important. Does sound has energy? Yes, sound has energy. How we can prove with the help of a mobile phone experiment? First of all, we can take a empty plastic container and a mobile phone. Initially, in the mobile phone, we are not on the music player. The open end of the container is closed with the rubber stack and tied with the rubber band. After that, we can keep some thermocol balls. You are observing up to 1 hour, there is no change in their motion. Next, the second time, repeat the same experiment by on the music player in the mobile phone by keeping the maximum value. At that time, you are observing that the thermocol balls are start the dancing. Is nothing but move up and down. That's why you say that here sound has energy. And next one, at the one more thing is also from the above experiment we conclude that sound is produce the vibration. That's why only rubber stack will start the vibration. Then thermocol balls is also dancing.